right, so we are just rounding it off to our very last panel discussion of the morning. It's been a very long morning, very early for me. So I'm going to bring on our presenters on in a little bit, and we'll have Dr. Carsten Giebeler joining us from Spectrolytic. Carsten, always good to see you.
Hi, Sanya.
Hi. We have Ameye from Fluitec. Always good to see you, yo. Thank you so much for
Hello.
all
Hello,
of your
Sanya.
support this
Hello,
morning.
Carsten. Good morning.
Hi, morning, Jill.
Hi. And of course, we have Rüdiger Krethe from OilDoc. So I have everybody with me this morning. Now, this is a good panel to be in.
Hello. Good morning, Sanya. Good morning, Carsten. Good morning, you.
Morning, Rüdiger.
Good morning, you all.
So I know this morning we're going to be talking about the main question: is oil analysis still relevant today? And since we've started a few hours ago, we've had so many great presentations with Hadi just rounding it off about AI and sensors. We had Dr. Abid talking about turbine oil, monitoring. And of course, we had Angus giving us some very good case studies in the UK based on what he's seen, what he hasn't, seen in the industry. So it's really good information that we've had so far. So I know this panel is gonna round it off, and we're gonna be talking a lot about, whether we think oil analysis is still relevant today. And I know this is not a one-word answer for sure. Definitely not. And shout out to Angus this morning for, doing that plug with the book. And one of the things that you may not have realized about the turbo machinery preventing varnish book is that Ameye actually wrote the foreword. And in the foreword for the book, you talks about the evolution of oil analysis. So I'm gonna ask you to give us a brief breakdown of that. Like, how has oil analysis changed over the past 10, 20 years? Because I know you've been in this for some time. So I know you can give us some very good information on that. How do you think it's evolved over the years?
Yes, thank you, Sanya. Let me first of all thank you for making an excellent job today. It was already exciting. You're doing that so naturally. So it's so we also see very good presentations. I would like to thank also the presenters. And you could see through the presentations also the expectations, the evolution on condition monitoring programs, the importance it plays, and so I'm very pleased that I can start off and this interactive session. Also, I think. Yes, well, let me tell you, 10 years ago, it went very fast. I think Rüdiger will certainly confirm that. If we think where we were 10 years ago, Rüdiger, I think it would be just very interesting to look at that. But 10 years ago, I went back and I made a little analysis. 10 years ago, MPC was not even accepted as a method. Today, we speak in all the presentations. I hear people speaking about MPC, and it was the first time that MPC was introduced. I know at that time we were starting the standardization process of MPC tests. Thanks to a lot of laboratories, including, for example, OilCheck, where Rüdiger was working at that time, the ruler method was implemented in 10 years ago. It was starting to get a good acceptance level, and look where it is now. 10 years ago, 10 years later, it's very well accepted by OEMs, and I don't think there's an oil analysis report who's missing ruler analysis. Grease analysis. Look at 10 years ago. Think about Rich Woesbach, who was coming up with his first testimonials about the importance of looking at grease testing. I remember also a discussion I had with Rüdiger on grease testing for like in paper plants in wind turbines, and where he also spoke about that. look the evolution that infrared has FTIR technology over the last 10 years has undergone. 10 years ago, it was used, yes, for some research applications, but today FTIR, looking at oxidation, water, TBN, TN, it's a well standardized test method. So yes, I think, and on top of that, if you look 10 years ago, how education and certification has evolved. I've never believed that it would have gone so fast. If you see STLE, ASTM, OilDoc, NORIA, ICML, ASTM, all bringing up these practices. So yes, I think the move from 10 years ago to now is, I would say, move away from pure oil analysis to condition monitoring, diagnostics, root cause analysis. I think that is the trend that I've seen over the last 10 years, and I think I've spoken enough now.
Oh my gosh, I can listen to you all day, but I'm gonna ask Rudy. Rudy, like you've been in this industry for quite some time as well. How have you seen that evolution with oil analysis? I mean, you gave us a little bit of a insight there, but I know you have some stuff that you could share with us as well.
Yes, we have done a lot of work together with your presentations about the ruler and so on. But let me sum it up in a very easy way. There are two things I have to consider to explain why this happens. We lubricate modern machinery. That means high downtime costs, high cost of the machinery itself, and the risk to lose money is much higher than before. That's the first one. But to lubricate this machinery, we use also modern lubricants and very, very long oil drain intervals. And that's the difference we have. If we only talk about the better base oils we use, the saturated base oils, to have a better oxidation stability, but beside that, they have lost the ability to dissolve the oil aging byproducts. That means the increase of viscosity we have seen in the past, don't see it in modern lubricants today. And even the increase of the acid number, the same story. That means the main facts we used in the to more or less to see whether we have oxidation or not, and all the things related to that, we have lost them. That's the first thing. And now, if you go to the analysis, I would say, therefore, the second thing is that we now have to replace it, and we did it. Therefore, in my opinion, the main development strategy of oil analysis the last 10 years, but even the next 10 years, is the monitoring of the additive condition. Because of the base oils are more stable, very easy way. We have to have techniques to get the antioxidant level, for example, and other additives. And the next thing is sometimes people think we have better base oils, and because of that we have no deposits because of the yes, from base oils, yes, but the depleted additives produce now the varnish and so on. And we will not see it in an increase of viscosity and acid number. We need not only the additive depletion to monitor using the ruler, the MPC. We need a technique to see the tendency of the oil to produce deposits. And therefore, that is the main driver today. And without that, it would mean, if we would work, to use your words, with the technology we had in the past, it's the same thing. We are driving on the highway at the night, switch off our lights. This we would do when we work like 10 years before. Okay.
Oh my gosh, I love that. Absolutely love that. And yes, I totally agree in terms of it's not just the oil analysis that we're going to evolve, the oils are evolving as well. So what we've used 10 years ago is not going to work today. Definitely not. And we have evolved, I would like to say. And that's why I like to bring in Carsten, because I know Carsten is like heavily involved in the sensor world. And you would have seen the changes in terms of moving from a lab base into the sensor world and into the sensor technology? And how has that evolved over the past 10 years? Because I know the technology we have today and that I've seen, like working with Spectrolytic, we did not have anything like that 10 years ago. Anything.
Yeah, sort of answering your question, I think, Spectrolytic, we are a little bit late to the party. So I think we're sort of more focusing on the next 10 years to come. So what, as the previous speaker, Mr. Hardydorf pointed out, there is people want data. People want data, and people want reliable data. The older generation that might know about the oils and the engines and all this stuff, that they're sort of slowly retiring, and younger generations are used to phones, tablets, and they need to have data presented in this format. And in order to do this, we inline oil condition monitoring sampling has always been there, but using data that are not really, I call them actionable. You can measure the dielectric constant, but what does a dielectric constant really mean in an oil type of thing? And so we really took the lead from the oil laboratories, where they use FTIR or whatever, where we really try to count the molecules, for not a better word, that are relevant to the application. Let it be the additives, let it be the stuff that causes oxidation, and try to provide this data to the customer so that they can use this data to make decisions, because that's what it's all about. At the end of the day, we are all trying to create to provide data that helps the end customer, basically to prevent unplanned downtime, because that's what costs the most money. That's what costs the most money. So, and what we are trying to do is not only provide a sensor, because I think the end users don't want to integrate sensors. The end users need a complete solution. They need a complete solution where they can ask you or tell you, I want parameter A, B, C, D.
Right.
And that's what you give them in the right format. And this is sort of where we see things going. And the closer you can provide data that matches the laboratory, which will always be needed, I think the easier it will get with what Mr. Hardy presented earlier on, to get all these AI models and the prediction and all this stuff. So that's how we see it.
All right, that's a good view as well, because I think one of the questions that always comes up is, will we see existing labs go away? Will there not be a need for them in the future? But like you explained, you'll always have the need for the labs. And Dr. Abed is actually asking a pretty good question here. He's asking if any analytical method developments to establish the correlation between TOFT versus TAN, MPC, and RPVOT. Well, don't hold back on us, Dr. Abed. Definitely, do you all see any sort of analytical method that could, do all of these together?
I think, well, if I, it's a funny question. It's a bit of a funny question, and I think it's a little bit a way of how do you say, how we approach things. So there isn't a method. Obviously, in inline you won't be able to say here's a method for everything. But what sometimes works, so you can find oil specific solutions. So we have oils where we get really good, very good correlation between whatever inline data and MPC and RPVOT. But then there are other oils where it doesn't work. But because we are working on inline installation, you only have one asset. And in this asset, they do not tend to change the oil every 5 minutes. This is So once it's set up, it sort of works. But what we can't, certainly this is not our approach. We can't say, oh, here's a method that everybody can use, and this is how it works. So this is, I think, more one for Rüdiger to see whether you can shut our eyes. We certainly can't.
I work with oil analysis for 30 years. And when I sum up in the beginning to give them the right setup, more or less, I would sum it up in that case. There's no single method on the market covering all oil changes we will find in practice due to oil oxidation and what else, what happens there. It is not there. And every method has some special setup, and then we need a combination. We need a combination. We even TA and an MPC, there's no correlation. Sometimes yes, sometimes no. In RPVOT, we know even there are some special things. Therefore, we will have cases like you mentioned, Carsten. There we have correlations, and in others not. And at the end of the day, very often even people in our lab ask me, we do the MPC for maybe per year several thousand samples, and if we sum it up, maybe only 20% are bad. That is a bad efficiency, more or less. I say no. Even to have the information, it's good. It's a reliable information, and we cannot say at the end of the day kick all these methods out, and we have at the end only one method covering all. We cannot have that, and therefore it will not work. Even online measuring and one very easy thing. We use the same sensor to measure particles by laser sensor online in the machinery. And then they send a sample to us in our lab. We measure using the same equipment, this oil, and we have different results. And sometimes people are wondering about that. I say it's very easy. We are measuring online. Your oil flows, has a temperature of maybe 50 degrees C. And now we should online have the same result, but we have the temperature of 25. And therefore there must be differences. And but if we do it right, we know that the online and the offline data work good together. Because we know we have the higher results because of we have due to the lower temperature, we have other saturation level even for the oil aging products. We know that if you explain that to the customer, it's very easy. But to bring together that the online sensor has a very big advantage. You get the result within a second, and we can go to your equipment. We can take a sample. Everything is okay. We go to your office, maybe 5 minutes later, you have a leakage there. We don't have it in our bottle, and even 5 minutes are gone. It's not that much, but the sensor gives you the warning directly. Of course, the sensor cannot be that detailed like we do when we apply maybe 20 different methods in the lab analysis to give the picture. But he gives the early warning and can explain the main things. And if you want to go in detail, we need a lab. And this will be in the future even the same situation. The more we learn, the better. The sensors are very clear. But I see the world very dynamically. There are that much changes. We have a lot of work even in the future.
We do. And we have a really good question here. Do you want to add anything to that?
On this question, no. I see there's a question who came in from.
There's a really good question here because I love this question from John.
It's the question. It's oh boy, yes, oh boy. It's the question.
Boy. It's one that I love definitely because ruler and RPVOT is something that we have going on in the industry all the time. People are battling with it. I mean, I definitely have a bias, and I will say that, but that's just because I know in terms of your reliability with the RPVOT, and I'm gonna let you explain this a little bit more. But I think ruler and RPVOT measure two very different things.
Correct.
And that is why you would see different results. Your RPVOT, it gives you something in terms of the results in terms of minutes, which is not entirely applicable to what you have in the field, whereas ruler actually gives you a quantitative vision of your antioxidants. So I'm gonna let you answer this question because I know this one is dear to his heart, and he's gonna help us. He's gonna help out our friend John this morning.
Yes, I think you answered mostly already, Sanya. If we go back 10 years ago, 15, 20 years ago, RPVOT, a test method who was established in the years 1960, mainly for steam turbine oil formulations to focus on phenolic antioxidants. At that time, turbine oils were using mostly phenolics for steam turbines, rust and oxidation, like they say, R&O fluids. From there, later in the 2000s, when gas turbines came on the market, higher oxidation stability was needed, and oil formulators were starting to blend phenols and amines, aromatic amines, as a synergetic mixture to give optimized oxidation stability. RPVOT values were then used as a method for new oil performance requirements, and you could see in 2004 with the new ASTM turbine oil requirements, they increased the minimum RPVOT value from 500 minutes to 750 minutes just to boost up the life of the oil. But an RPVOT test method, like you said, is measuring then the oxidation stability, and that is not only the antioxidants, that can be also some of the natural antioxidants, the base oil, basically. The difficulty with an RPVOT test is that, especially with new generation of fluids consisting of high amount of aromatic amines, gives high oxidation stability, means you could have like 2,000-3,000 minutes of RPVOT. The difficulty with that method is to see the drop of oxygen, pressure drop detected by an RPVOT method, which needs specialized, with really good interpretation specialist. Therefore, the ruler was over the last 10-15 years mostly replacing RPVOT, also because of OEMs which see that an RPVOT test did not have the same repeatability as a ruler test method. But on top of that, I would say, like John is saying in his email, is that you need to make sure that they are using the right standards. And I see already an answer from Gwyn, from Polaris with the same answer, first of all. But secondly, more important, that the laboratory is trained well and is using the right test solution and measuring individual amines and phenols, because it could be that the lab is reporting a drop of phenols to till 10%, which is pretty normal, and you could still have like 90% of amines. And not always in interpretation of the reports, the end user understands that this 90% of aromatic amines is what you need to look at. And that's also what ASTM standard is saying, that you need to look at the remaining antioxidant percentage to judge the remaining useful life of the oil. So there is mostly the confusion coming from John, and I think it's also good to ask always your lab, and if I see labs, to show the ruler graph, see the graph and really understand, am I measuring the right antioxidants? So that's in a nutshell, but in general, I would say the correlation is pretty good between ruler method or voltammetry and RPVOT. That is, I think, and also don't forget the test method. RPVOT is a method in minutes, 1,000, 2,000 minutes. Ruler method is measuring in 20 seconds, just for a lab, you can imagine. And that's making the link to data generation. Let me make the link then to the question that the point Carsten and Rüdiger brought up. Today in oil analysis, it's a matter of data, digitalization, like they say. So the more data you produce, you're going to be more powerful, and therefore I think the right test methods need to be selected.
Oh yeah. Anything you want to add to that, Rudy? I know you want to add something to that.
Yeah, I want to add something. we should have in our mind even the RPVOT. We test the oil with a bulk temperature of 150 degrees C. Even that's not the reality. We know that I'm a mechanical engineer and I have special knowledge in tribology from the beginning of my studies. The testing, very often we have to shorten the time of testing,
Right.
and that we do temperature and oxygen, you know that, and or the load and the mechanical testing. What else we do? And sometimes, every time we have the question, is this method we use there the reality or not? Yeah? That means the more harsh the conditions are, the more or the higher is even the possibility that we even here are far away from practice. And now one question I have to provide a training these 2 days. One question of one of the attendees. He asked me, what about the technical data sheet of a turbine oil? What I can learn from the data there? And then he mentioned about the RPVOT.
Right.
And he showed me a data sheet, RPVOT, 3,500 minutes. What do you think about that? I told him, if I see that, I'm very critical, that I will not judge about this turbine oil good or bad on one number. But if I see this high reading in RPVOT, I go to the other tests and I go to element analysis, to infrared, to see how this oil was done. Because of that, it is more or less very dangerous if one test is that high, that you have a solution, that you use a special additive package to have a high reading in the test, and in reality, you produce deposits without any end, especially in high temperature oxidation environment. And that's even here, we should even have in our mind. What I have learned in 30 years of oil analysis, put all values together and paint a picture. And only one test can lie very, very easily.
Yeah, and I totally agree with you, because I know, and we spoke about it earlier this morning when we had a lot of the other presenters. We have had changes in base oils. We have had changes in lubricants over the years. They're going to be evolving. They're going to be hopefully getting better. But we will see those changes. And if our tests don't update according to those changes, then we're kind of measuring something from 10 years ago versus what we have today. So it's not an accurate measurement in terms of that. Carsten, do you want to add anything to the ruler RPVOT?
Oh, no, that's well above my head.
Because I know it is a question that we always get. Everybody comes up, RPVOT versus ruler. Again, RPVOT will give you a value that you may not be able to correlate in the field in terms of minutes. The ruler would actually give you what you have in your oil at that point in time. So I think that actually provides a little bit more value to what you're looking for in terms of monitoring your oil and what's going on with it. Yo, did you want to add something?
Yes.
I know you want to add something.
No, well, I think I would like to, because the time is running. I think I want to continue on discussion that Carsten was saying, which was interesting. It's data, the future, the next 10 years will be important with the online analysis and detection. I fully agree. And also, I would say that yes, the question comes from Mr. Mohammed Asim. How reliable is online monitoring system? My experience is that today I've pretty good experience with online monitoring. Think about water already, and I think viscosity. But there's new technologies which will be needed. Like Carsten will explain and already said about oxidation. Even I would say some of the possibility to look at antioxidant depletion online for critical equipment. But don't forget that I think online monitoring will be mostly important and needed by our end users, industry, as part of sustainability. It's clear that today, with everything which is happening around us with the climate change and CO2 reduction, or challenges that plants have today to meet this CO2 reduction, that lifetime extension is going to be for lubricant assets, because they are an asset. They're not a consumable. Let's change that mentality and making them an asset. The online analysis will be very important for that, to be proactive, on time, generate enough data, which can then be double-checked by specialized laboratories, service companies, and then make sure that you come to an I would say a totally different approach and optimize the lifetime. So I think that is a suggestion I would like to discuss, and maybe then Carsten can answer the question on how he finds his products to be reliable.
No, Joe, you are exactly right. So first of all, we get this question always: how reliable are an online monitoring system? You know what? The biggest problem with the current process is a human being. You know, somebody has to go there and take a sample. Somebody then the sample sits there for weeks. Then at some point somebody decides to ship it, maybe. Then it comes to the laboratory. So depending what the person has done the night before and whatever process they have run. So the human factor in all of this is by a mile the biggest influence on reproducibility in the lab process. So we have installed our sensor. So we at Fluitec, we do the mid-infrared spectroscopy type, and then we combine it with viscosity sensors, particle counters to really provide a complete solution. And they have been validated by Exxon, by Castrol, by every end user, and they match the laboratory results from there. But that is not the point what we are trying to do. So what the lab people do, they produce what I call absolute value. As Rüdiger explained, you go time to time, you take a sample, you get it analyzed, you compare it to your OEM specification, and see whether it's still within the warranty guidelines and all these things. And these periods where you take sample, everybody wants to extend them because you have to send people to the engine, that's risky, blah, blah, blah. So what our sensor, what we are trying to offer, is, which doesn't exist at the moment, is looking at the rate of change of a parameter. But looking at a rate of change of a parameter that's relevant, i.e. the oxidation, i.e. the additive depletion, i.e. the, I don't know, nitration, depending, like water. Depending, obviously, that does depend on the application. So, and the rate of change, how things behave over time, this gives you 100 times more information about what happens in your asset than an absolute value. An absolute value of 18 doesn't mean anything. But if you see, look, here is now an asset where it has increased from 13 to 18 in 1 week, and all my other assets, it increased from 13 to 14, then you bloody think, well, it's not quite right. But, and this is a fundamental difference where, and I think this is why the question, does it match the lab analysis and all these things, is this sort of happens automatically in a way, but it's not the purpose. We are not trying to replace a lab analysis, because as Rüdiger said, in a lab, he can bring in all his knowledge, he can do 18 different tests to really dig down. But by looking at the rate of change, looking at the range of change of parameters that the end user understands, because it's exactly the same parameters that they get from an oil analysis report, then they can really early on identify the assets where something is wrong. And then they can go to Rüdiger and say, look, Rüdiger, what is that? Yeah. What's the reason for this? Can you dig down? And then together we can work out how to improve things. But this is sort of the thing this is a new aspect that we believe we bring to the puzzle is the rate of change.
Absolutely, I'm with you. And let me add something to that. Sometimes people think sensors work against labs. They don't. They work perfectly together if the customer wants that. Yeah, sometimes they don't understand it. I explain it even in my training this way. When we use oil analysis by sampling technique, we can monitor very good, slowly ongoing processes like the normal oil aging, like oxidation, like additive depletion, and so on. Every time we have in our mind that the condition of change is more or less in a wide range, more or less stable. Right. Very, very fast changes we cannot have because of if we don't take the sample in the right time, we don't have it. The sensor can do that. And if you have a look to the past, very often I discuss with maintenance managers here in Germany, they tell me the following. If I go 10 years back, I had 10 people to do the work. Today I have 2.
Yep.
And in the past, we did oil analysis and we did manual inspection. The guys went to the asset to see what's going on. And now we have to, I have only 2. We have to replace this gap. And sensors cannot only fill this gap, I'm pretty sure. If the sensors are well selected, they can do more than the guys going around and see the machinery more or less only from outside. They can measure things from inside, and therefore I see there's no battle between the sensor and the labs. They work perfectly together because of the sensor can do things what we can't. And we can do with the right mixer, even clarify the details. And the reliability of online monitoring systems, there's an easy game, like in the oil analysis. If you have only one parameter can you not tell you that much. And even that, and Carsten knows that, I love the infrared sensors, because of the infrared sensor will not only test one wave number, but the right combination can do the job. Right. And you can do it more wide if you say now the infrared and viscosity and this the more values we have, the better we can paint the picture and the more reliable is the picture we have.
Yes, and I think also what you're saying, I believe fully, Rüdiger, is the fact that we have less resources in maintenance, so that they need to be better trained. So it's important that we, that's why we have this LRVS, by the way, to make sure there's an online platform, learning platform. Next year in June, in May, we have OilDoc in Rosenheim again to bring all the professionals together. But the training is so important, education of these resources, so that they are aware of already experiences today in the industry, and also how they can configure their programs to the future, because their input will be important. Because like you say, before there were 5 people, now 2. Secondly, I think the accessibility of some of industry. We see, for example, and I know labs today are very active in the wind energy to monitor the gear oils or the pitch control hydraulic oils. Well, that is another good example of where online sensors are already used today, but will be more used because the accessibility is so difficult. Or think about a nuclear plant or subsea applications. So I think there is really a wide range of applications. Last week I was speaking to people, operators in the mining, and they say for us it's always a mess to take these samples and send it out. So if we could have at least, like Rüdiger is saying, a signal when things are suddenly changing, then we can take action. So it has so much benefits, but the oil analysis still today, the condition monitoring, the basics, where I think we struggle still with is that the financial benefits. We need to maybe Sanya, you want to address that subject?
Oh yeah, for sure. And I think a lot of people, a lot of plants, they're doing cutbacks. They're doing, they have budgets in place and they're like, they can't spend too much money. And they think that it's too much of an investment to do oil analysis. But when you really think about it, the benefits of doing oil analysis, of catching that failure early enough, can actually save you millions. And I know we spoke about that earlier this morning in one of the other presentations. Once we have critical equipment, being able to catch that you have a trend in change, because at the end of the day, oil analysis is always going to be that. It's going to be trending the changes that we have in particular parameters. And once we can trend that and make sure that we keep it below the alarm levels, you can maintain your equipment. You can, remain running. And that's the justification that you will have for actually implementing oil analysis. Or in some cases, if you have a little bit of extra budget, you can do those oil sensors and, actually put those in. But they definitely have to work together. Unless they work together, then we're not going to get the full benefits and the full value that they can offer. And I love what Rudy and Carsten are saying in terms of, everybody has to work together. The labs, the oil analysis sensors. So I think from our audience so far, one of the things we should take away is that we're not doing an either or with oil sensors and labs. We have to work together with these. And as we evolve, as technology evolves, we need to start getting up with the times, for sure. Get up with the times and, upgrade your facility, upgrade the equipment that you have, because the oils are changing. Your values are going to be different from 10 years ago. So you can't use those same, reference values. And I know somebody talked about that in the comments. If you're using your baselines, make sure it's the most recent ones. And that's another thing with oil analysis. I know Gwyn was talking about that. Thanks, Gwyn, for pointing that out. Make sure you have the most relevant and the most recent samples, because with condition monitoring, you're always going against your baseline. You need to know what your baseline is. That's the first part of it, because that's what you're comparing is against. So I wanted to talk a little bit about machine learning. And I know Hadi covered some stuff about AI a little bit earlier. What do you think? And he broke it down very nicely earlier on. How do you think we can do AI with sensors, Carsten? I'm asking you that one.
I'm not sort of the AI expert, but I think it's as Mr. Hardy said, rubbish in, rubbish out. So that's sort of the fundamental thing. So obviously, what we are trying to do with our sensor or with our solutions is to provide what we call actionable data. So we give as an input meaningful data, i.e. a particle count, an oxidation value, not a temperature or a pressure or the color of socks that the operator is wearing, that you then all throw into a huge database, and then you run some whatever models over it to get correlation. And I think in a lot of cases, this is what's happening at the moment. People have loads of data, they throw it in a database and run algorithms over it, and out comes a correlation, as Mr. Hardy pointed out, and then who understands why this correlation exists? It becomes harder and harder. So, and I think in order to do it, that was also my question about the installed base, I think you need quite a lot of assets and data to do it. So because we are sort of providing more or less sort of the same type of data as an oil laboratory now. So in my head, you can combine our sensor data with historic oil analysis. Oil analysis. So, and suddenly you have what I call sensible data, sort of chemically relevant data that you can put into your AI model and combine it, so that the overall, if you talk about money, the overall cost of setting up a model in terms of how many training sets or whatever you call these things you need. You have all the training sets because you can go back 30 years in your whole analysis if you want to, and you can combine it with the inline sensor where you now get a reading every hour or however you set it up. I think this will have a huge impact on the acceleration of using AI or machine learning type systems, because the data are now, they mean something. You don't, in the olden days it was mathematics, now it's called AI. Interpolating these things out is relatively straightforward, and then you combine it with all the other algorithm types that might be there. But that's sort of my take on it, but I'm not the AI expert.
We had the AI expert before. Rudy, I know you want to say something about that.
Only a very short note as a mechanical engineer. When I started my studies, one of our professors in technical mechanics, how to calculate maybe the dimension of a machine element or what else, and he told us the following: you want to become an engineer, you need you need to create models how you calculate something, and at the end of the day, you should be able, if you have the result, to have a feeling or a knowledge whether I can trust this result can be true or not. This is very important, because if you can calculate many things by numbers. And I think we produce, even in our lab, and especially if you use sensors, such a big mass of data, we cannot do it manually. And the data they are worthwhile. Even in our lab, very often I explain customers, hey, if I go back in history, I see your machinery the last 10 years. I see that changes in trend. I see that something is different than before. I can see it in the trend. Other problems maybe are the same as before. And you have to use data to do that. And at the end of the day, again, we cannot do it manually with the mass of data we have today. We need help. But we should be that intelligent at the end of the day to have a look at the results, to see whether they are good or not to say this is a good or bad technology. That's not the question. To learn together, to apply it better, to have at the end of the day the better result. But we must do it.
Yes, definitely. And again, we have to work together at the end of the day. I know you want to add to that.
And equipment are also becoming more demanding. Let's not forget that. And it's not just turbines, but we are more and more involved, for example, with manufacturing. See how today automotive industry is changing face with this whole EV transformation. But the quality requirements, the just-in-time delivery availability of components is today so critical. If you produce, think injection molding machines, and your components that you produce, aluminium components for aerospace, today they're all fighting to get all these components in time in the airplanes. I think there it's clear that AI will be going to be important. Think about if you could combine the need of production need together with the criticality of machines and the delivery delays that are going to be created, depending on the data which is produced by the performing of the machine, the performing conditions. I think it's vast, so vast, and I think oil is only this little piece, but let's start with that already, because like Rüdiger is saying, and Carsten, there is a massive amount of data already available. My point is, which companies are going to be the leading companies to be having that data shared? That's I think my only question I have, because the data, no doubt, it's there. and there's a lot of universities, and so there will be the challenge and bring companies work together on platforms so that then we can make sure that we take the maximum out of this AI. And but yes, in 10 years' time, Sanya and Carsten and Rüdiger, we will be back hopefully on the same platform. And we can ask ourselves, do you remember 10 years ago we talked about where condition monitoring and AI will be? I'm 100% committed. It will be a success. Absolutely. Yeah. I have no doubt about that.
Yeah, absolutely.
Yeah, and I think one of the things that we're seeing is that AI is able to actually do a lot of the things that we could not have done before. Just as you mentioned, it's a large amounts of data out there, and now we can actually collect the data and store it in a particular place and actually use it, have models to run on it. So I know Carsten was talking a little bit about that before, and Rüdiger, you as well. So I have a couple of people like just joining in, and they're saying, you know, why wouldn't anybody want to do oil analysis on their plants? You need to know the condition of your operating machinery. Of course you do. It's a small price to pay just to, you know, find that out. And I know Matt had to join out, drop out for a little bit, but we've had a lot of good comments so far for the morning. I just wanted to do a final round of wrap-up thoughts on the oil analysis topic that we're talking about today, because it is very relevant. We've seen it. We've talked about it. It definitely is something we need to combine with oil sensors and AI and machine learning. And I feel like every other technology that's going to be coming out in the next 2 or 3 years, because the rate at which we are evolving, it's going to be different for sure. So what do you think, as you started off with the question, how do you think we can actually change this in the next 10 years, or, you know, have something? No, I'm just giving you can look into your crystal ball a little bit and tell me what you think it looks like in the next 10 years. And Carsten, I know you're at the forefront in terms of sensor technology. How do you think your sensors are going to evolve in the next 10 years? They're already small. So
no,
they can't
you know, they are not small. They are small. They are small. As I say, from our side, so we are going to add more. We call it laboratory equivalent inline sensor solution. So the next thing we're going to bring out is an inline elemental sensor, so that you can do elemental analysis inline. Again, you know, within reason. Within reason, so to provide more and more actionable data that forms part of the puzzle of the puzzle. But I think the biggest problem in all of it is a little bit with the end customer. That if the end customer has an oil analysis budget, and only looks at it at the oil analysis budget, and doesn't look at the overall product life cycle cost, for not a better word. And I think there are different companies that function differently. There are some companies that are more progressive, that sort of have a wider view, but there are still a lot where at least we see, why should we use a sensor if an oil analysis costs, I don't know, whatever it might be. You know, so it's missing the point a little bit from our side. But you know, there you can't really say anything because they are right. You know, but again, we are adding we are not doing an oil analysis. We are adding additional information that, but if the customer doesn't see it like this, that's a fair point. But I think this change in attitude of saying, look, here is a critical asset, as one of the guys said, why wouldn't they do it? But a lot of people just don't care, you know. Or that maybe they do, but not enough. So that's why I think where things need to change a little bit. But it's an overall, I think we all have to prod the end customer and point out how important it is to to look at sort of preventive stuff.
Definitely, Rudy. I know you want to add to that. Where can we see oil analysis in the next 10 years based on everything you've seen?
Maybe oil analysis has to do less routine testing, routine analysis, but more be the key for clarify the details, what happens in practice. When we work together with sensors, by the way.
Yeah.
And then even we in our lab will use those technologies to do more with our data, to be at the end of the day more efficient, even in recommending actions and increase the reliability. That is very important. What we have to do, and if we can automate a little bit better the way of sampling and information sharing, therefore we have our app in development, and we use it, of course, for years to make it more smart, to bring not only the sample in the laboratory, but the right information to have the basis to do it right. And then I'm pretty sure we are still in the business in 10 years, of course.
For sure.
I'm sure you will be.
For sure. And you, rounding off thoughts on this one.
I can only add, I think fully agree with Rüdiger and Carsten, especially Rüdiger, what he's saying, that we should go for more specialized oil analysis, for root cause analysis. Also, think what I was saying about sustainability, lifetime extension. If you want to assess the oil quality, is it viable for lifetime extension? Do you want to add another 30% of the lifetime of the lubricant so that you can avoid interventions, increase liability, reduce the risk, because we all know that every oil change is always containing a certain percentage of risk. If you can avoid that, and also once again think in function of sustainability. I think oil analysis will be driven by these requirements from CO2 reduction and footprint reduction. So I found that, and their own online sensors will be absolutely playing a major role.
And a very short note, and we sum it up what we discussed even in this hour. But we have to take our customers with us, and their education is very important.
Absolutely, I could not. Rüdiger, let's make some promotion here for OilDoc next year in May.
Maybe we have this conversation in person in Germany next year in May.
Yeah, so that will be absolutely education. I could not agree more. Thank you.
Definitely. So, guys, thank you all so much for your time this morning and for sharing all of your knowledge, because you all are the top ones in the industry. I'm glad that I was on the panel with you all, and you all, made the time for me this morning to do this and to share with our audience as well all of the information on oil analysis. I think a lot of people got very important information. If you took anything away from this panel, know that condition monitoring is where you monitor changes in your oil. So it always goes back to that, making sure you have a proper baseline to compare. So thank you guys so much for all of our audience that joined in from all over the world, Singapore, Malaysia, the European region, people who got up from the Americas. I'm sorry that you all had to wake up so early. But thank you all so much for just joining us and always been a part of LRVS. This is our last LRVS for the year, and we will be back next year, 2025. And we will be looking forward to seeing you all here again. So, stay tuned. All of these recordings will be available on YouTube. It's going to be available on LinkedIn for the rest of the day for sure. And just keep looking out. Connect with all of our speakers. So another thank you, very quick thank you again to Dr. Abid, to Angus for joining us, and of course to Hadi for sharing so much great information with us today.
Thank you, Sanya. Thank you, Sanya, especially for hosting, coordinating, and having this panel. You did a fantastic job. So thank you so much. Wonderful.
Always
Sanya, for you.
Okay.
All right.
Thank you very
Bye,
much.
everyone.
Thank you.
Rüdiger.
Bye-bye.
Bye. Take care. Bye.